Hey, all out there. Thanks for tuning in to check this out mathematics. And I encourage you to like and subscribe to this channel and put some comments down below and watch more of the videos that I've posted on YouTube. And if you've seen some of my videos, we've been talking about Pythagorean triples and formulas that generate Pythagorean triples. And so now we're going to look at these formulas that generate Pythagorean triples and go into the underlying concepts to understand why and how they generate Pythagorean triples. And so now in the previous episodes, we talked about these three formulas that generate Pythagorean triples. And so if A, B, and C are form a Pythagorean triple, then these formulas will form the A, B, and C that gives you a Pythagorean triple. And we had three of them here. And we're going to talk about this first one here. And then in the later videos, we'll talk about the second one and this third one as well. All right, so let's first look at this idea. This Pythagorean triple generating formula here is based upon a number m that is an element of the natural numbers. And the natural numbers are the counting numbers, 1, 2, 3, 4, and so on. And so if we have a number m from the counting numbers, and we substitute that m number into this arrangement here, these algebraic expressions, this will give us an a, b, and c, where a squared plus b squared equals c squared, a Pythagorean triple that is a solution for the Pythagorean theorem. And in this arrangement, the c value, that's the value for the hypotenuse or the diagonal, will be one more than the b value. And you can see that from these algebraic expressions here. This algebraic expression is one more than the previous algebraic expression. So this is the portion that will generate the b value, and the c value is one more than that portion that generates the b value. Okay, so let's understand how and why this generates Pythagorean triples. In the previous videos, these are the Pythagorean triples that were presented that work for this formula here. And so notice that the c value is 1 more than the b value here. 13 is 1 more than 12, and 24 is 1 more than 24. And so if we let m be 1, and we substitute that into the generating formula here, then we will get the 3, 4, 5 Pythagorean triple. And if we let m be 2, we'll get the 5, 12, 13 Pythagorean triple. And if we let m be 3, we'll get this one, 7, 24, 25. And then there were 3 more that we presented in the previous videos. And so if m was 3, then we would get the 9, 40, 41 Pythagorean triple, and m is 4, we get 11, 60, 61, and m is 5, we'll get 13, 84, 85. And those Pythagorean triples are up here on this poster that I have in the back here. And you can, if we take a look at that, there's the 3, 4, 5 Pythagorean triple there. And then we have the 5, 12, 13 here. And 7, 24, 25. And then, let's see, here's the 13, 84, 85. And, oh, and then we missed the 11, 60, 61 here. And then, oh yeah, we had the 9, 40, 41 here. Okay, and so I encourage you to go back and watch the previous videos where we talked about this neat arrangement of all the Pythagorean triples, where the digits are just 1 or 2 digits. That means that the highest value, the C value, is all under 100. All of these are under 100 here, the A, B, and C values, and it fits into this nice 3, 4, 5 arrangement here, where you have this the 3 squared here, and the 4 squared here, and the 5 squared here. Okay. All right, so let's look at these Pythagorean triples. And the first thing you might notice is that the A value and the C value are both odd values. 3 and 5, 5 and 13, those are odd numbers. 7 and 25, odd numbers. And same is true here. 9 and 41 are odd, 11 and 61 are odd, and 13 and 85 are odd. And then the next thing you might notice is that the middle numbers, 4 and 12 and 24, those are all even numbers. And that's true of these other ones here. 40, 60, 84. And what's more is that they're multiples of 4, actually. And in mathematics, we have a fun way of calling those numbers that are multiples of 4. We call them the even numbers. So true. I'll do a video about that later on, the even numbers. And so, so the 4 and 12 and 24 and 40 and 60 and 84, those are all multiples of 4. 4 times 15 is 60, and 4 times 6 is 24. And so you can see all the middle numbers are, the B values are multiples of 4. And so let's understand how it is that this formula that generates Pythagorean triples gives us an odd number here and an odd number here, and it gives us an even or actually a multiple of 4 here for the B value. Okay? All right. So, in mathematics, we have odd numbers and even numbers, and you already know what those are: 1 and 3 and 5 and 7 and 0, and well, we're not talking about 0 because we're talking about the counting numbers. So, but 0 is even number. Okay, and so 2 and 4 and 6 and 8 and so on. Okay, so we have these odd numbers and these even numbers. And so if we pick an M value, the M value could be odd or even. And so what we want is we want this M value to make an expression that will be even, or I'm sorry, excuse me, odd, right? Odd. Okay. Okay. And so we want the first number in our Pythagorean triples to be odd numbers: 3 and 5 and 7 and 9 and 11 and 13 and so on. And so we want to fashion an expression using m values, and these m values can be odd or even, and we want them to always come out odd. Well, if we take m and we double it and say we have 2m, well, 2m will always be an even number, okay? So you say 2 times 3 is, if m is 3, then 2 times 3, that's 6, you know, so you've got an even number. And if you have m is 8, well, 2 times 8 is 16, so you've got an even number. So a way to guarantee that your expression will always be even is to, of course, multiply it by 2, and that's what it means to be even, you know, that it's a multiple of 2. Okay. And so now, after every even number, 2 and 3 and 4 and 5, you know, after every even number, you got an odd number. And, so the way to guarantee that you create an odd number is to say 2m plus 1. So now, no matter what m value you use, yes, 7, 2 times 7 is 14, plus 1 is 15. Okay, we got odd, okay? Or if we say 2 times 6 is 12, and then plus 1, that's 13. Oh, okay, so we got odd numbers all the time. So this expression always leads to odd numbers. And so that's why we have that expression here in our formula that generates Pythagorean triples. We start off with an odd number. Okay. And now you will notice that 2m plus 2m squared, well, that's going to be an even number. You've got 2m, that anytime you multiply by 2, you get an even number, and anytime you add an even number and an even number together, this is another even number, 2m squared, you know. An even plus an even, say, you know, 6 plus 8 is 14. You get another even number, okay? So this is an even number here, guaranteed. And then notice this is one more than that even number, just like this is one more than this even number 2m. And so this 2m squared, this 2m plus 1 is going to be an odd expression. And 2m plus 2m squared plus 1 will also generate an odd number. So this formula for generating Pythagorean triples, like these in our list here, is working so far, because we have odd numbers here for A and for C. And for A and for C, you know, that's what we're making here, is A, B, C combinations. And so this arrangement here, do this right, okay? So this arrangement here with the formula that generates Pythagorean triples here is giving the 2m plus 1 is giving us an odd number, like the 3 and the 5 and the 7. And the 2m plus 2m squared plus 1 is also giving us odd numbers, like the 5 and the 13 and the 25. All right, so what we just want to, what we just need to understand is that that middle expression, 2m plus 2m squared, is going to give us an even number, like the 4 and the 12 and the 24. And what's more, it's also going to give us an even number. That means a multiple of 4. Okay, so how is this always going to be a multiple of 4? Well, let's examine. Okay, so recall that when we have a value, a number m, right, say it's 3, then we say 2 times 3, and that gives us 6. So, if m equals 3, then 2 times 3 equals 6, and we have an even number. Okay? And, even if it's odd, okay, even if it's an odd number, oh, it was an odd number. Okay, even if it's an even number, of course, say 6, then you're going to have 2 times 6, and that's going to be 12, and that's an even number. So whether you have an odd value or an even value, when you say 2 times that value, you're always going to get an even number. Okay. And so the 2m squared is of the same nature. Here's m squared. That's just still an m value, so to speak. It's just a value. And so you're multiplying it by 2, and so you're going to get even numbers. That's always going to work. And notice that whenever you add an even number to an even number, say you say 6 plus 8, you get an even number. Okay? And so when we're adding these together, 2m plus 2m squared, that's going to give us an even number. Okay? And just on a side note, let's take an odd number. So an even plus an even number gives us an even number. 6 plus 8 equals 14. And if you have an odd number plus an odd number, what's odd about that is it gives you an even number. Okay? So you say if you have 7 plus 9, that gives you 16. So you have an odd number plus an odd number. That's always going to give you an even number. Okay. And so then the only way that you're going to get an odd number is if you mix it up. So if you have an odd number plus an even number, such as 7 plus 6, then that's how you're going to get an odd number. So the only way to have a result of an odd number is to mix it up. Just a little neat thing. You may already know that. Okay, so we can see that this expression 2m plus 2m squared is always going to be an even number, because you have an even plus an even number, which is always going to be even. And that's what we have here, okay, for the b value. And in all of our Pythagorean triples here, these are even numbers here in the middle, whereas these are odds, right? Okay. All right, so we got them to be even. How is it that we can have them be multiples of 4? Well, the way to make sure that we have a number that's a multiple of 4 is to say multiply an even number times an even. Okay, so if you have say 6 times 10, that's 60. Okay, and so if you have an even number 6 and another even number 10, well, then you get 60 here, and 60 is 4 times 15. Okay, so the way that you can guarantee to get a multiple of 4 is to make sure that you have an even number times an even number. Okay, and that's because the simplest multiple of 4 is 4, of course. 4 is 4 times 1, And if you multiply 2 times 2, you know, that's the first thing we learn in mathematics. 2 times 2 is 4, and you know, 4 is a multiple of 4. Okay? So that's what we want to have happen, is an even number times an even number to give us a multiple of 4. And so how can we make sure that that happens? Well, let's see. So if we have 2m, this is always going to be an even number. Okay? It might not be a multiple of 4. For instance, if you have 2 times 8, that's 16, and that's a multiple of 4. But if you have 2 times 7, that's 14. And this is not a multiple of 4. Okay, so whenever you take 2 and multiply it by some number, you're going to get an even number, of course, but you may not get a multiple of 4. So we have to, and that's because m might be odd, and when it's an odd number, we don't get multiples of 4, because we need another even here. You see that? 6 times 10, even times an even number. Of course, when we have another even number, like 2 times 8, we get 16, or for instance, if we have 2 times 6, we get 12. And so as long as we have an even number and another even number multiplying together, we're going to get a multiple of 4. So this is not always going to, it's always going to give us an even number, but it's not always going to give us a multiple of 4, because that m value might be an odd number. So what we need to do is take that 2m and multiply it by another expression. And that other expression is m plus 1. Okay, Mr. Donald, where did you come up with it? Okay, I'm going to tell you. That's why you're watching this video, right? Okay, so if m is an odd number, like say 7, then this next expression, 7 plus 1, will guarantee that we have an even number. See, check that out. So if we have m as 7, well then m plus 1 will be 8, and we'll have an even number times an even number, which will give us an even number. And of course, as we just established, we can just rewrite this. And see that 2 times 8 is going to give us 16, and 16 is already a multiple of 4, and we take a multiple of 4 and multiply it by any number, we're still going to get a multiple of 4. Okay. So if m is odd, well then this is going to guarantee us that we're going to generate a number that is a multiple of 4, because we're going to get, even if this is odd, this will be even. Okay, so we'll have an even times an even. All right, so now, of course, if the m value is even, you know, we say 2 times 6, and then we say 6 plus 1. Well, 6 is even, so we already have an even number times an even number. That's 12, and this is 7, you know. And so we already have 12 as a multiple of 4. And so anytime you take a multiple of 4 and multiply it by any number, you're still going to get a multiple of 4. So this expression here will guarantee us that we'll have a multiple of 4, because even if the m is odd, the m plus 1 will be even, and we'll have an even times an even. Or, of course, if the m is even, well, then we're already there. We'll have an even times an even, which gives us a multiple of 4. as we suggested in this previous discussion here, that the way to get where is it? A multiple of 4 is to have an even number times an even number, right? Anytime you have an even number, say 6 times, say 10, right? We got 60, and that's 4 times 15. So any times we had an even number times an even number, that's guaranteed us to give us a multiple of 4 there. And you know that's because there's a 2 times 3 and a 2 times 5, and that's 4 times 3 times 5, and that's the 4 times 15. And so if we multiply an even number times an even number, then we're going to have factors of 2 and 2, which is going to give us the 4. So that's always working. Okay, so we have established that this 2m times m plus 1 is always going to give us a multiple of 4. And so we'll say that it's some number k times 4, and that signifies that this expression is a multiple of 4. It's 4 times some number. Okay, and so now when we use the distributive property, you remember the distributive property, we can take that 2m and multiply it through the parentheses like this, and that will give us 2m times m plus 2m times 1. So we're multiplying the 2m times m and the 2m times 1 there. And that gives us the 2m squared plus 2m. Or, you know, we can still write it the other way if we would like to. And so now we have that middle expression, 2m plus 2m squared, that we had in our formula that generates Pythagorean triples here, 2m plus 2m squared. So this expression always gives us a multiple of 4. So there we have it. We have, this is always an odd number because it's an even plus 1. And this is always an odd number because it's an even number plus 1. And this is always an even number, and what's more, it's an even number, which means it's a multiple of 4. You gotta quit with this even stuff, Mr. Bell. Okay, so this always generates a multiple of 4. And so now we can see that this expression is always leading to the nature of our Pythagorean triples that we have here, odd and a multiple of 4, odd and a multiple of 4, and so on, odd number, multiple of 4. And so that's, and here are other 3 that we happen to like here. Odd and multiples of 4, you can see that's true there. Okay, so this Pythagorean triple generator here does give us the nature of these Pythagorean triples. Okay, so that's some of the underlying concepts there. And then the only thing we want to do in the next video is show that when we take the 2m plus 1 and the 2m plus 2m squared and the 2m plus 2m squared plus 1, when we take that series of expressions and we substitute them into the Pythagorean theorem here. So that means what we're going to do is instead of a, we're going to put 2m plus 1. And instead of b, we're going to put that 2m plus 2m squared. And that's going to give us, we have to square these, of course. Okay, so if we take the expression that matches up with the a value and we square it, and we take the expression that matches up with the b value and we square it, then we should get the c value squared. And that's what we're going to show in the next video here. Okay, so this is what you want to tune in next here, that this a squared plus b squared equals c squared. That's what we're going to show next, so that we can prove that this formula is a solution for the Pythagorean theorem all the time. All right, thank you for tuning in, and we'll see you back here at Check This Out Mathematics. And subscribe to the channel, like it, and comment, and watch more. That's how I can keep making more content for you. All right, take it easy. Mr. Adolph signing off.